I got an 80.
Yeah, same here.
I didn't
Same here.
think, I thought I'd do a little better. I didn't think I'd get like 100 or anything, but I don't know where I went wrong.
Yeah, same here, because, I mean, I went through it and it seemed easier than I was thinking it was gonna be. And yeah, like, I was pretty bummed when I got the 80, and then I'm like, well, it's still a good grade, but yeah, like, I was expecting a little bit
Yeah.
that I was getting it, a little more, so.
I know. I was like, I thought I understood, but I obviously don't because,
Right.
yeah. And I
Yeah.
haven't read any of chapter 9. So.
Yeah, I just kind of skimmed through the first little bit of it, but yeah, unfortunately not
I
too
started
much.
watching the video, but I didn't get too far. So, oh well. We'll do what you can do, and hopefully I'm not a weak link.
Yeah.
Hey, Micah.
Hey, how's everyone doing?
Going good. How are you, man?
Just really tired and sleep deprived.
Dude, isn't that the truth? I feel like I never get caught up.
I know, I feel you. Oh, it's awful.
Yes, it is. And it doesn't get better as life goes on.
That's really, oh man, that's
Comforting.
not
Reassuring,
good.
Christine. Thank you so much.
Very optimistic.
Yeah.
Uh,
So, Micah, how far along did you get on the reading?
so I finished most of it. I feel pretty confident on this one.
Oh, really? Okay, good.
Yeah, yeah. Why? How about you guys?
I didn't get anything read.
Yeah, and
Oh,
I just kind of got through the first few things. I mean, like, it was all making sense, um, but yeah,
I'm,
I'm
I'm
gonna
going to
leave
let
it
you
at.
guys teach me then.
okay, we'll go through this. I mean, okay. All right, let's get the quiz opened up and hopefully the things I read make sense to me.
Sounds good. I did start watching the little video, but I only got about halfway done. So.
Yeah, I finished the 2 videos, and that's what kind of connected a lot of it for me. And I
Okay.
just hope the questions are really similar.
Cool.
All right. Group meeting quiz. Are we
It looks like.
live already?
Are you
What's up?
recording?
Or recording? Yeah.
Yeah. I started.
Sweet. All
And we
right.
need the applet that says for this quiz.
Hey, Christine, thanks again for the that sheet too. That really helped.
You're welcome. Yeah, I don't even know what I would add to the sheet to help me do better on the test. So I'm kind of sad it didn't show what I missed, so that I could
Yeah.
figure it out. But that's all right. Maybe she'll tell us after everybody's done, and it's I don't know.
Did you do
Anyway.
pretty well on it, Micah?
Not as well as I wish I would have.
Yeah.
But yeah, I was kind of in a rush yesterday, so I feel like I didn't do as well as I would have if I had more time. But
Yeah, that's kind of how we felt too. So,
yeah.
right.
Hopefully next time. Anyways, what?
Oh yeah, for sure. All right. So, which hypothesis involves equality? So, I believe that one's the null hypothesis, right?
Mm-hmm.
Yes, because the alternative would be
When it's
inequality
not.
or greater than less than kind of thing, right?
That's
Exactly.
what I understand.
Because yeah, it's just saying it's the status
What's it?
quo. So like, we're testing if this is exactly the same or if it's not.
Mm-hmm.
Okay. What is a true hypothesis, or is that just a bogus term?
I didn't see that one in any of the readings.
Okay. So it's probably just thrown in there. Sounds good.
Or unrelated, yeah. Hopefully. All
right.
So the next one says information. The p-value is the probability of obtaining a sample statistic at least as extreme as the one that was actually observed. Use this information to answer the next question. Question 4. Remember that the p-value is the probability of rotating. Okay, it's repeating. When computing the p-value, which hypothesis do you assume to be true? The null, right?
Yes, because
Or wait, oh man, I need to think of those example questions. So, that's right.
Yeah, I mean, I would think so, because at least as extreme, at least as extreme as the one that was actually observed.
Yeah.
So, like, greater than or equal to? Is that what it's saying?
At least. Yeah, yeah. Because if it's as at least as extreme, then yeah, it would be either matching it or more. So
Yeah, I don't
yeah,
know. That one's worded really weird. I'm not sure. I guess we could just go with one, and then if it's not, we go with the other. So
yeah.
yeah, I'm going to go with null.
Okay. All right. So the next one says, suppose the null information
okay,
H.
wait. I just went back to the chapter. So for that last question, it says in the chapter, it says, assuming the null hypothesis is true, what is the probability that we would observe a sample mean as extreme or more extreme than the values we observed? This probability is called the p-value. So it's the null hypothesis is true, or the b.
Oh, okay. So we're assuming that it's the null.
Yep,
Okay. Sweet.
Yeah.
that was good. Okay, 5. Suppose the null hypothesis has a mu equal 10. Which of the following represents the alternative hypothesis for a two-tailed test?
What's a two-tailed test?
Yeah, that's what I was just thinking.
I don't know.
Oh boy.
Oh.
Does it have to
Well,
do with coin tosses? And is there?
it says that when it's not equal, then it's two-tailed. If it's less than, it's left-tailed, and if it's greater than, it's right-tailed.
Where does it say that?
I just searched for 2.
Ah,
Came
that
up with
works
that.
too.
So I don't
Okay,
know.
so
I don't know
in
where it
our,
explains it, but
so tell me again what it says. Two-tailed.
is well, let's see. When the mu does not equal, it's a two-sided hypothesis and two-tailed.
Okay.
When the mu is less than, uh, it's a one-sided hypothesis and left-tailed. And then when it's mu greater than x, it's one-sided hypothesis again, but right-tailed.
Okay. So this one is going to be not equal.
Yeah.
Okay, so 5 not equal.
So the left-tailed is less than. Mu is less than 10. That's number 6, right?
Yeah.
And then right-tailed is greater than?
Yeah.
Woohoo.
Okay. Hey, I like these ones. These are easy. All right. So here we go to number 8. Here's the information. Remember that we determine the outcome of a hypothesis test by comparing the p-value to the level of significance, or I think that's the alpha symbol, I forget. Use this information to answer the next two questions. Number 8, which relationship would result in failing to reject the null hypothesis? Ooh. Part of me is thinking it's the second one. P-value is less than the alpha. I don't know. Any of you have any thoughts on that?
Okay, so if the p-value is low, reject the null. What's the question asking again?
Oh, wait. Let's see. So it says which relationship would result in failing to reject the null hypothesis. So actually, would that mean it's the first one? P-value is greater than?
Well, here it says, okay, so this is the level of significance about alpha. And it says, how do we decide if the p-value is small enough to reject the null hypothesis?
Mm-hmm.
We need a way to determine if there is enough evidence to reject the null hypothesis that does not depend on the data. We need a number that can be used to determine the p-value is small enough to reject the null hypothesis. This is called the level of significance. But we're not talking about the level of significance, right?
No, we are, because the answers are its real. So yeah, level of significance, which is denoted by alpha. So what is the relationship of p and alpha when we reject the null? Which
P must be low. P must be lower than alpha.
Than alpha. Yeah.
Right?
Yeah.
So if p-value is greater than alpha, we fail or reject. Oh, wait, no. If the p-value is less than alpha, we reject the null hypothesis, right?
Oh, right. Yes.
If
Yeah.
p is greater than alpha, we fail to reject. That's right. We either reject or we fail to reject. We don't accept. I don't get that one, but okay. So now let me go back to the quiz. So we're going to say the p-value is.
So we're going to do p is greater than if we're failing to reject.
Okay, cool.
These dumb wordings are going to kill me. It's probably why I didn't do as well as I wanted on the exam.
Yeah.
Anyway. Okay.
And this next one's just the one we were talking about. Which one is rejecting it? So it's going to be p is less than a, or alpha.
Yep.
Good.
All right, so number 10. All right, so here's the information. An insurance company is reviewing its current policy rates. When originally setting the rates, they believed that the average claim was about $1,500. They are concerned that the true mean is actually higher than this. Use this information for the next two questions. Question 10. Which of the following would be the appropriate alternative hypothesis? HA.
So it would be greater than. Because they're concerned that it would be higher?
Because they're concerned it was higher. So yeah, the opposite would be saying it's higher. Of the null. All right.
And then which of the following would be appropriate null hypothesis?
That one's going to have to be equal.
Equal.
Okay.
These questions are nice. All right, so number 12 says the insurance company assumes the distribution of the sample mean is normal. Is this a good assumption? Oh, there was information I missed. Sorry about that. The insurance company randomly selects n equals 40 claims and calculates a sample mean of x bar equals $1,650. Use this information for the next 3 questions. Okay, so they assume that the sample mean is normal. Is this a good assumption?
Did it say the original say it was normal? It didn't say anything about being normal.
Nope.
But the sample size, oh, wait, the sample size is bigger than 30, so it would be normal.
Okay.
N equals 40, so it's greater than 30, so that makes it normal. Right?
Yep.
Yeah. So it's a good assumption?
Because the sample size is large.
Yeah.
Sweet. I need to write that down.
And then 13, what theorem or law justifies your answer to the previous question? Oh, don't ask me this one.
I think this is central limit. Because law of large numbers is close to the mean.
Yep.
Yeah, so it's central limit theorem because the law of large numbers is just about the mean mainly.
Yeah, and then so central limit is about seeing if something's normal.
Okay. All right, so question 14. The following, which of the statistic as defined in this lesson? Wait, let me see.
Wouldn't it be X bar because we're taking mu would be the whole population mean, where X bar would be the sample mean, correct?
You know what? I thought it was going to be
That-
X bar too, but I just looked at the lesson, and it keeps saying that the test statistic is Z.
Okay.
So I'll have to go through and find why
Read
that is.
about that.
Wait, does Z mean Z-score in this case, or does it mean something different?
Right, that's what I was just thinking.
And can I tell you that I think is one of the things that throws me so much is they use the same things, like there's X and there's X bar. Why can it be like G instead of X bar? Or I don't know, just they reuse things, it seems to me, and I get thrown off. Anyway, so
Yeah.
we just go with Z
I get
and
that.
See what it says?
Yeah.
Yeah, cross our fingers. All right. Anyone want to read the next one?
I will. The historical mean of sales receipts at a grocery store is 150 with a standard deviation of 40. The store manager suspects the average has decreased. She sets up a hypothesis test with the hypothesis, the null hypothesis, the mean is 150. The alternate hypothesis, the mean is less than 150. She will use a level of significance of alpha equals 0.05. She then takes a simple random sample of 36 sales receipts from her store and computes the sample mean to equal 144. Use this for the next 4 questions. What is the z-score associated with this test?
Okay.
So is that the normal? We'd use the 144 minus 150 divided by
So since this one, I believe, has a sample mean,
yeah.
I think you have standard deviation over square root of n. I'm not totally positive.
Is alpha involved in anything, or is it just back to the z-scores that we did previously?
I'm pretty sure it's just finding the z-score how we've been doing that.
Okay. So we're then on the bottom, we're going to divide by 40 divided by the square root of 36, right?
I'm pretty sure.
Sounds good to me. Not that one. This one.
So you have negative 0.9.
I do.
Okay.
Mm-hmm.
And then round to 3, so negative 0.900.
Or did we do it wrong?
I'm gonna do it one more time.
I wonder if it is without.
Oh,
Without the n, with it just being the standard deviation, it's negative 0.0225. So, I don't know.
So I'm looking at step 4 of I don't know what on the book, and it's got z is equal to x bar minus mu all over just the standard deviation divided by the square root of n. And then they're going to use the applet to do the probability. But I didn't see if there was something that said about if the alpha has any effect or change in, is there a different formula that uses the alpha somehow?
yeah. Well, I just got something different than you guys, so now I'm concerned. Oh man.
What'd you get, Riker?
0.176.
What numbers did you use?
So I don't know. I might have flipped the subtraction. I did 150 minus 144,
Oh,
and then
yeah.
and then for the bottom, I did the. Let me see. So it would be 40 minus the square root of 36.
Okay, yeah, so it's going to be x bar minus the mean. I think you did the mean minus x bar on top.
Oh, I flip-flopped it.
And then on the bottom, it's going to be divided by, not minus.
Or oh wait. Oh my goodness. Yeah, I totally did that. Wow. Gosh darn it.
So are we being thrown just because it's telling us to have multiple decimal or places after the decimal? And
I think so. I think so.
Yeah.
I think if we stick to the 0.900,
Yeah.
okay.
I think we're good.
okay, and then what
And
is
what's
the p-value?
Oh yeah, so
is
we
that
plug in the
the
z-score.
probability value, right? So we go to the applet.
Yeah.
Yep, and put in the z-score, and it should be what pops up as the area, right?
Yeah.
It's negative 0.9, right? Though.
Yeah. Yeah.
So we got an area of 0.184.
Yep.
Mm-hmm.
Okay.
All right. So are we ready for 17?
Yes.
All right. So what inference what inference would you make about the null hypothesis for this problem? So reject the null hypothesis or fail to reject the null hypothesis.
When we reject it,
Wait, why would we reject it?
Well, the sample mean is less than the hypothesis mean. So the alternate hypothesis is mu is less than 150 and the sample mean is 144, so it'd be less. I don't know what the probability.
Yeah, I think as long as the probability isn't like whatever, like 0.00000 blah blah blah,
Yeah.
then your sample, there's a pretty good probability that your sample is correct. Is that
Oh, okay.
correct? Or
That makes sense.
because that's what we're testing, right? We're testing our sample.
Yes.
So then yeah, I'm pretty
Reject the null
sure.
hypothesis.
Yeah.
Okay. Reject.
So then 18 asks, what is your conclusion for this problem? We have sufficient evidence that the true population mean is less than 150, right? Because the sample mean is less than 150?
Well, see, and that's where I'm going back to. Part of the reading was saying like, even though you have one sample that proves your hypothesis wrong, that doesn't
Mm-hmm.
mean that it's strong enough necessarily. So that's what's
Okay.
kind of
Oh
mixing
yeah,
me
because
up.
that could be
Like,
a rare event, right? That's what it was going into.
right.
So the probability number tells us more about that then?
Well, I think it's saying, so just with what you've come up with so far, what is it? And so I would say, I don't know. I would still think it's insufficient, but that it's the mean is less than.
Well, then that
I
changes
don't, I
our
don't know.
answer for the one above.
Right, right. So I don't know when you have strong enough to reject it.
So are you
So
thinking the
so
third one?
I mean, it's either uh, the third one or the fourth one. But yeah, I get what Christine's saying. If we're saying that we have strong enough to reject it,
Okay,
then
here's
we
something.
have sufficient evidence.
Yeah.
If the p-value is small, that implies the z-score was very large or far away from zero. In other words, this sample mean was far away from the population mean. In this case, our z-score was 6.669, standard deviations below the mean. It is very unusual to get a value of sample mean that is this far from the value of the population mean given the null hypothesis. This implies that it is not plausible that the mean is equal to this particular problem. We reject the null hypothesis and conclude that there is sufficient evidence that the true mean body temperature of healthy adults is not 98.6. So I guess I was hoping that
It's
would tell
saying,
me what.
so it's saying, um, if it's if your sample is close to your uh, whatever, if the z-score for your sample is close to your mean of your population, then that's not sufficient evidence proving it wrong because it's so close. Is that what it's saying?
I don't know for sure now.
But that doesn't. I don't know if me summarizing that even made sense because the null hypothesis is equal to. If it's anything different, then you have to reject it.
Right.
So
Are we accounting in the level of significance? Maybe that's what makes the difference, is if it obeys the law of significance or not.
yeah, I think we are missing that.
because the law of significance in this case is 0.05.
And so if the So 4.4 is where it talks about level of significance. And that's where we were, if P is low, we reject the null. So that's where we talked about if the P value is less than alpha, we reject the null hypothesis. So is our P value less than the alpha?
Okay, gotcha. So P is 0.184. And then we compare it to 0.05, right?
So our P value is greater than the alpha.
Right.
So we should
that
fail
means,
to reject.
correct, fail to reject.
We're going to change 17 to fail to reject.
Yeah.
And then 18, our conclusion is we have insufficient evidence that the true population mean is less than 150. Or we have sufficient evidence.
So,
Only.
so it says that if the p-value is greater than a or than alpha, we fail to reject the null hypothesis. That means that there is insufficient evidence to suggest that the mean perceived general health of patients at blah 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 is worse than the general population. So insufficient, but I don't know the second part. Well, see, if we're failing to reject the null hypothesis, then that means that we have insufficient evidence that it's different, right? So that
we have insufficient evidence that the true population mean is less than 150?
yeah.
I think, maybe.
Yeah.
Oh,
Because if
okay.
it's
Because that's the alternative that's trying to oppose it, right?
right.
Or
Right.
Because if you go to the other insufficient comment, it says we have insufficient evidence that the true population mean is 150.
And
But we do
that's
have
saying,
population.
that's saying that we're
yeah.
rejecting.
Yeah. So no. I think I'm wrong here. I think it's the fourth one. We have evidence that the true population mean is less than 150, right?
No,
This is
we
throwing me
don't
off.
have them.
No, I think I should stick with the third one. Oh man.
Yeah, well, it's so hard because like I feel like they're all. I mean, two of them are kind of saying the same thing, right? Like,
Yeah.
and then the other
Yeah.
two are kind of saying the same thing. But man, I'm gonna have to reread this whole thing. I mean, I think
Well, we
we're
get to
getting them
take the
right,
test
but
twice, so it'll be
yeah,
okay.
yeah.
We'll fix the ones we miss.
The what?
Okay, this one, question 19 says there are two types of errors that can be made when performing a hypothesis test. Which one involves rejecting the null hypothesis when the null hypothesis is true?
Type
I just
one?
started that part in the video, and I don't know. Is it type 1?
I'm like 75% sure. Because they use like an analogy with like lawyers and stuff, and innocent until proven guilty. So
Thanks, man.
I feel like it's type one because they made it sound like type one was when you're rejecting the actual truth. So, and I think the other videos where they went over the homework problems, those went into it too, but I didn't have time to finish those. Let me see.
Here's one comment. It says, whenever we reject a true null hypothesis, we say that a type 1 error was committed?
Wait, so were we right?
Yep,
Okay, whew.
type 1. Save it.
All right.
I think we're right.
Fingers crossed. All right, last one. A researcher decided that instead of using a level significance of alpha equals 0.05, he will use alpha equals 0.01. Which of the following will be true? The probability of type 1 error will increase. The probability of type 2 error will increase. The probability that the null hypothesis is true will decrease. His experiment will more scientific. Wait. His experiment will be more scientifically valid. Oh boy. I don't think it's the last one. Thanks. Oh boy. I feel like I need to do some reading because I don't know anything about if you change the level of significance. Let's see. Hmm.
So here it's saying if alpha is allowed to be very large, then the probability of committing a type 2 error will be very small. A level of significance of alpha equal 0.05 seems to strike a good balance between the probabilities of committing a type 1 versus type 2. That didn't answer my question.
Well, and it also says that alpha is basically like measuring, what did it say that? The level of significance alpha is the probability of committing a type 1 error. So if we change it, if we decrease alpha, then we're going to decrease a type 1 error. So the first one is not right.
So which one's not right? The first one?
Yeah.
Okay.
So does that mean it's number 2?
That's what I'm going towards.
Okay, then pick it.
Okay.
Yeah, I feel like the last two are bogus. Oh wait, I said last one, but no, we have 21 questions.
I know, dang it. I thought that was the last one too.
Whoops. Okay, so if alpha equals 0.05, compute the probability of committing a type 1 error. Round to 2 decimal places. Okay. Based off of what information again?
It's up above 16 is all the information, but are we doing? I don't get. I don't understand how to.
Yeah, I don't understand this either.
Isn't that what we did when we did the 0.184 or 1.184? Weren't we figuring the probability then?
Let's see. I think because in the summary it says typical values for alpha are 0.05, 0.1, and 0.01. So I wonder if like we just choose one of those three,
Wait.
like that's computing alpha, or
It might be more simple than we're thinking, because I don't think we need any of the above information to do this. Because if it's 0.5, so if you go to 4.5 in the reading, I think the answer's there. Because it says we choose alpha to be some small number so that the probability of committing a type 1 error is low. The most common value for alpha is 0.05. This is equal to 1 out of 20. So when the null hypothesis is true, there's a 1 in 20 chance that it will be rejected at the 0.05 level of significance. I feel like somehow that's our answer, or somewhere in there is our answer.
yeah, no, I agree. Because we're just choosing one out of those three, right?
Yeah. Let me see, could it?
Oh. Yeah, no, if alpha
is
equals 0.05, that is equal to 1 over 20. So I think we just put it says round to 2 decimal places, so all we're doing is 1 over 20. Right? Oh, that's 0.05. What?
Wait. Yeah, no. I'm so confused by this. 1 in 20 chance it will be rejected.
Do we put it into the applet?
Question 15 we got wrong. I just put in a number and submitted the quiz because I figured I haven't done the reading I could figure out. Then you guys can get a good score on your test. So
Okay.
while you've been figuring that one, okay, and I got 21 wrong. So just 15 and 21 is everything else is good. So I don't know.
Okay, so
it feels like the answer would be 0.05.
I know, that's what I'm thinking. But because we do try to find the probability in the applet. That's what I'm trying to think. But I don't think we'd plug what alpha is into the applet. I'm thinking, yeah, I don't know.
That's going to give you right at the whole. I mean, that's right at the 0, the mu of 0. Kind of, or not mu of 0, but it's a 0 probability. If you type in 0.05, it gives you a 0 probability.
Huh.
I don't think that's the right answer, but I could be wrong.
I mean, I would just, I guess, the only thing that makes sense is 0.05, which I don't think that's it, but I don't even know what else, right, Micah? Like,
I feel like the way I'm interpreting the reading, it makes it sound like it has to be 0.05, but
yeah.
But
no, yeah, especially because it's like, oh, that's 1 over 20. And then 1 over 20 is 0.05. So it's like, I don't know. Okay.
But it comes out as 0%, and that doesn't make sense.
Yeah. Huh. That's weird. Okay, and then what did we do for 15? Oh, that was the one where
we figured out the z-score.
Right, that was the one we were going back and forth on getting tripped up about 3 decimal places.
Yes.
Yeah.
But
So I guess
didn't 16 like use the information from 15, or am I wrong in remembering that? Because it says 15 is what is the z-score associated with this test, and then 16 is what is the p-value associated with the z-score from the previous question. So we got 16 right, but we got 15 wrong. But I put in 0.9, not 0.900, because the zeros after the 9 are redundant, aren't they? Or is that where I did
wait,
wrong?
hold on. Did you do negative 0.9?
No, I did not. I just typed 0.9.
Okay. Yeah, I think it's negative.
Oh, wait.
Negative
So,
0.9.
oh, shoot. Then I want to make sure I didn't make the same mistake. For 16, did we have negative 0.184 or was it just 0.184?
It's positive. 16 is
Yeah,
positive.
Oh, thank goodness.
It should be negative, so it should be.
Okay.
And then I still don't get the last question. It doesn't make sense to me.
Oh,
But
okay.
maybe after I read it.
So 0.05 is right.
It is?
Yeah.
Oh my gosh, yes! I did something.
The answer is 0.05.
Yeah. And then for 15, yeah,
It should be negative 0.9.
negative 0.9.
Okay, so, whoa, what am I doing? I didn't save my answers. That's all right, I can see it again, right? Okay, so I'll just retake it and add those two that I missed, and we'll be good.
Sweet, guys. Good job.
Awesome.
Thanks for helping.
Yep. Thanks, everyone.
All right. Good luck with everything. We'll see you guys on Tuesday. Right?
Yep.
Yeah,
Enjoy your
have a great
weekends.
weekend.
Yep. Thank you.
You too. See you guys.
All right, thank you, guys.
Bye.
Bye.